So we're going to be using the distributive property. A lot of people call this the backwards distributive property. What we're doing is instead of multiplying these things, we're actually going to be taking it backwards and we're going to be factoring it. And factoring means the process of expressing a polynomial as a product of a monomial and polynomials. So what we're going to do is to find, I need a pencil, not a highlighter. Find the GCF, greatest common factor. And we're going to make it so that it looks like the distributive property. So if I look at these two, if I just look at the numbers, look at 12 and 16, what is the biggest number that goes into 12 and 16? Well, 4 is. And if you look at it, they both have A's. So what we're going to do is we're going to take out that 4A. So I'm going to divide this by 4A. What do I get? I get 3A. Plus, if I divide this by 4A, I get 4. So to check your work, boys and girls, if I was to multiply this, I would get 12A squared. If I was to multiply this, I would get 16. Is that what we started with? It sure is what we started with. So that's exactly, I didn't mean to, just wanted to get rid of the line and this line. Oh, did it again. Oh, I know why. There we go. Okay, so this is my answer. Okay, over here. What is the biggest number that goes into this? Well, 20, 45, and 35, they all end in 5. So we know for sure 5 goes into it. And then each one of them, this one, first one has an x squared, second one has an x squared, third one, they all have an x squared. They don't all have a y. So I'm going to divide this by 5x squared, divide this by 5x squared, and divide this by 5x squared. The first one I would get 4y squared minus 9y minus 7. So if you were to multiply that 5x squared back through, you would get what we started with. So let's look at this one. What goes into each one of these numbers? If I look at it, does 3 go? The 33, we have 3 times 11. 3 doesn't go into 121, but 11 does. And then each one of them has at least an n squared in it. So I'm going to divide each one of these by 11n squared. So 33 divided by 11 is 3. N to the third divided by n squared is n minus, if I divide by 11n squared, I would just get 11. Over here, they're all even numbers, so I know that 2 goes into it. This one is 2 times 7. 7 doesn't go into 6 and 7 doesn't go into 10, so 2 is the only number that we can take out. But if you notice, I have an A, I have an A, I have an A. So I know that A can come out, but this one has a 2, this one has a 1. So all we can take out is one of those A's. Then if I notice, each one of them has a C in common. And the most amount of C's that have in common is one of them. So I'm going to take this, I'm going to divide this by 2AC. So 14 divided by 2 is going to get me 7. A squared divided by A is going to get me A. B squared stays where it is. C divided by C, there's nothing left. Minus, divide this by 2AC. I get 3, the A's cancel out, and I have 1 C left over. Divide this by 2AC, and I just have a 5 left. Now, do you have to write that dividing underneath? No. Okay, so here we have The 1980 eruption of Mount St. Helens, Washington's Mount St. Helens, had initial blast with a velocity of 440 feet per second. The expression 440 t minus 16t squared minus the height of a rocket erupted from the volcano after t seconds. Factor this. So I have 440 minus 16t squared. Okay, so I don't know. Does 16 go into 440? I don't know that off the top of my head. So I would use a calculator. That is if I can figure out where my calculator is. There we go. 440 divided by 16. It does not go in evenly. 440 divided by 8. Oh, 8 goes into it. How did I know that? I just tried it. I didn't know. Only one of them has a t, so I need to do this. So I divide by 8 here, and I would get 55 minus, divide by 8 here, and I would get 2t squared. And there you have it. Okay, a golfer hits a golf ball with a velocity 112 feet per second. The expression 112t minus 16t squared represents the height of the golf ball. Factor the expression. So I have 112t minus 16t squared. So, again, does 16 go into 112? Oh, it does. It goes in evenly. They both have a t, so I would have a t here. So I'm going to divide this by 16t, and I would get 7. Divide this by 16t, and I would just get t. And there you have it. So we're going to use that to do a little bit more. And this is what is called factoring by grouping. So what you're going to do, there are 4 or more terms. Terms have a common factor that can be grouped together. There are at least 2 common factors that are identical or additive inverses of each other. Okay, so we're going to look at this. So a lot of teachers teach it like with a line here. Some teachers teach it, you put parentheses around it, like so. We're going to go with the slash. I'm going to put a slash here. And I'm only going to look at the first 2. What do they have in common? Well, 2 goes into both of them, and u goes into both of them. So I'm going to put this other part in the parentheses. I divide by 2u. What am I left with? I'm left with a v. Plus, if I divide this by 2u, I've got a 3. Then I'm going to look over here. I'm going to do plus. What do these have in common? They have a 5 in common. So if I divide this by 5, I get v. If I divide this by 5, I get 3. Now, if I'm looking at this, do you notice that these are exactly the same? So that's what's in common with this. So I'm going to take that out. I'm going to factor that out. That means if I divide this by this right here, these cancel. What is left over? Don't I have a 2v left or 2u left over? Then over here, I'm going to divide this by v plus 3. When these cancel out, I'm left with the plus 5. And voila, you have it in factored form. Okay, so let's try it again. We're going to come over here. I'm going to put a line right here. I'm going to look at my first 2, not even looking at my second 2. What do they have in common? They both have a t. So if I divide this by t, I'm going to get w. If I divide this by t, I'm going to get 10. Now, the next one over here. Do you see how they both have negatives? That this is a negative sign? I'm going to factor out a negative. And then what do they have in common? They have a 2 in common. I'm going to factor out a negative 2. So if I divide this by negative 2, oops, not 2w, just negative 2, I'm going to get w. If I divide this by a negative 2, I'm going to get plus 10. Now look at those two sets of parentheses. Aren't they exactly the same? So I'm going to take out a w plus 10. So I'm going to divide this by w plus 10 and divide this by w plus 10. When I do that, this cancels and I get a t, minus this cancels and I get a 2, or a minus 2. And there you have it. Okay, so here. So I'm going to go here. What do they have? The first two have in common? They have a 3m in common. Okay, when I divide by the 3m, I get 7. Divide by the 3m, I get minus p. Then over here, what do they have in common? They have a 4 in common, so plus 4. If I divide if I divide this by 4, I get p. Divide this by 4, and I get minus 7. Now, are these exactly the same right now? No, they're not exactly the same. But could I make them the same? Yeah. What if, instead of taking out just a 3, I took out a negative 3? I divide that. That would change to negative. This would change to plus because the signs would change. So let's look at that. I would have now negative 3m. I would have p minus 7. I would have plus 4. And then I have p minus 7. Now, as I look at it, are these two exactly the same? They are exactly the same. So I'm going to divide that out. So I'm going to take out a p minus 7. And I'm going to divide this by p minus 7. And when I do that, I get negative 3m. And when I divide out over here, p minus 7, I get a plus 4. Now, could you write this as 4 minus 3m? Yeah, same thing. Okay. Oops. So here we go. We're going to look at this. I don't like the leading coefficient to be negative. So a lot of times I take out the negative. So negative 3, and then they have an x squared in common. So I'm going to divide both of these by negative 3x squared. And I'm going to get x. And negative, I don't know why I did that. Negative 3x squared. And I'm going to get minus 11. Then over, I never even drew that. What do those two have in common? They have a 4 in common. So I'm going to take out a 4. When I divide by 4 here, I get x. When I divide by 4 here, I get negative 11. Are the two sets of parentheses the same? They are. And then negative 3x squared plus 4. Again, I really don't like that negative to be in front of that x squared, but that's how it has to go. Okay.